Hello friends, in this session we will see some numericals on compensators and controllers. Let us begin. Yes, so if you see here dear, what is happening? See, a double integrator plant, none of our business. What is the plant? G of s equal to k upon s squared. Okay, h of s is given as 1, is to be compensated to achieve the damping ratio of zeta equal to 0.5 and an undamped frequency of oscillations of omega n equal to 5. Which of the following compensator g of s is suitable? Now see here, what I am asking you is, let us see. You please tell me, all these parameters zeta, omega n are all have to be improved. You just tell me, are they steady state parameters or transient parameters? Definitely they are transient parameters. And we are talking about compensating the transient parameters, rather improving the transient parameters. Am I right? Yes. So if you check out this particular summary table, you see that transient behavior, who gives you transient behavior best, transient response is increased for PD. PD means lead, which means out of these four options, I want to find which one is the lead. Lead compensator is the answer. So if you see, option D is not the answer. Why? Because you have S in the denominator, which means it is PI. This is gone. Similarly, this one cannot be there. Why? Because S minus 6 means that it itself is unstable. S minus 6 is a 0. What I'm saying is, again, if you think of, then here you have this 6 which is here, and you have this 8.33 here, minus 8.33. Still we are not interested in this C. Getting my point? What about B? What about B? If you see S plus 9.9 and S plus 3, so if you see 9.9 is here, minus 9.9 comes here, and this minus 3 comes here, which means if I am standing at the origin, I see pole first. Yes, I see pole first, right? Which means even this is lag, so this we don't want. Now let us think of A. If I see here, what is there? S plus 3, which means 0 is at 3, and where is the pole? Pole is at 9.9. Pole is far away, minus 9.9, which means A is the answer, because this is the lead compensator. Lead compensator in the sense my life is leading, means it is stability. Stability in the sense I should see 0 first rather than the pole, right? Yes. Yes, dear. A unity negative feedback closed loop control system with a transfer function. So this is the closed loop transfer function, okay? Yes. And a controller GC of S in feedback path, okay? For a unit step input USI, okay? The transfer function of the controller that gives minimal ESS. Now see, here two things we need to understand. What are they expecting us to do? They are expecting us to improve the error. And error is a steady state parameter. Steady state parameter. Which means definitely I don't want PD and I don't want lead. That is for sure. But I need to check whether can I use PID or not, because see, g of s is given. What is characteristic equation? Characteristic equation is s squared plus 2s plus 2, right? Denominator of this one is the characteristic equation. This characteristic equation is there. What are the poles? What are the poles you get? If you find out the poles you get is -1 plus minus j1. This means that system is itself stable. System is itself stable, which means that we do not need this derivative component. This means that either we need pi or we need lag, which means this d will not come, because this d is a PID controller. This will not come. Then this one is a lag lead one, so C also cancelled. Let me think of A and B. What we want lag, right? Lag in the sense what? I am standing at the origin. Lag in the sense my life is quite unstable, in the sense I have to see pole first. I see, and this is going to be the 0. So When will this happen? This happens when this becomes -1 and this is -2, which means option B is the right answer. Option B is the right answer. This is the lag one. That's it. Option B is the answer. Right? So if you just check out by this summary itself, we can solve almost all the problems, right? Yes. Now let us think of third question. Third and the final question. Yes. So if you observe, a open loop transfer function OLTF of a plant is g of s equal to 1 by s squared minus 1. Okay. Now, if the plant is operated in unity feedback configuration, then the lead compensator that stabilizes the control system is. That is the question. Means they are themselves saying that they need lead compensator. Okay. Now, if you check out what is there with A and B, what is happening in A? A, is it a lead compensator? No, because this 0 is in the right half, which means definitely A is not the answer. Now, what about B? What about B? B, if you see this, if you think of this 2, which is the pole, and this is the 0, 4, -2 and -2, which means it is lag, which means B is also not the answer because they are asking us the lead compensator. B is not the answer. Now, if you think of C, C and D, C and D both are lead. C is also lead, D is also lead, which means, but what is the change? Here you have 10 and here you have 2, right? Which means what? Which means what? I need to apply Routh-Hurwitz criteria and try to find this value of k marginal. Let us try to do that. Let us see what happens. Rather than taking this exact thing, 10 and 2, this 10 and 2, I will rather assume it to be k. Okay, so let me assume that gc of s is equal to k into s plus 2 upon s plus 10. Okay, yes. So this one, it looks like this somehow, right? This is g of s, this is gc of s compensator, and this compensator is nothing but what? K times s plus 2 upon s plus 10, right? Similarly, g of s is what? G of s, it is nothing but 1 upon s squared minus 1, correct? Yes. Now this is how it looks. Okay, this is the thing we have got. Now what will be the characteristic equation? What will be the characteristic equation? If you see, it is going to be, let us say, because see, what will be this open loop transfer function? By the way, this open loop transfer function will be nothing but k times s plus 2 upon s plus 10 into s squared minus 1. Is that correct? Yes. Now what is characteristic equation? Characteristic equation is nothing but 1 plus this one equal to 0, right? So if you do that, you get s cube plus 10 s squared, right? Now what does it mean? Therefore s cube plus 10 s squared plus, this becomes your characteristic equation. Now let us form the Routh array. Routh array. How does that form? S cube s squared s to the power of s to the power 0. We know we have to write the alternate terms. So alternate terms in the sense, this is 1, this is 10. So alternate in the sense 1 k minus 1. That's it. So 1 k minus 1. Similarly 10 and 2k minus 10. 10 2k minus 10. If this is right, then last I should also get 2k minus 10. Now here, what comes here is going to be this symbol, this into this minus this into this upon this. So it becomes 10 times k minus 1 minus 2k plus 10 upon 10, right? Now if you think of, if the system has to be stable, which means this one, which means this has to be greater than 0 and this has to be greater than 0. What does that mean? Let us take here. So 10 times k minus 1 minus 2k plus 10 upon 10, right? Right, this should be greater than 0. This 10 goes there. What do you get? You get 8k greater than 0. Therefore you get k greater than 0. Means k should be greater than 0, that is for sure. Next condition what you get, let us see from this one. What do you get? You get 2k minus 10 should be greater than 0, which means 2k should be greater than 10, which means k should be greater than 10 by 2. Therefore, k should be greater than 5. Correct. Now, if you see, k should be greater than 5. Is 2 greater than 5? No, which means it is not the answer, which means option C is the correct answer. Option C is the answer. Getting my point? So, in this way, the whole chapter has been completed. Thank you.